What's up, guys? It's Mr. Bringle, and today we're going to be talking about different types of graphs that show motion. Okay, so the two types of graphs that we're going to look at are a distance versus time graph and a speed versus time graph. Now, you've briefly been introduced to both of these types of graphs through previous notes, but we're going to cover them in a little bit more detail in this lecture. So the first type of graph that we'll look at here is a distance versus time graph. Now, the title of these graphs is always going to be in the same format. You're always going to write whatever's on the y-axis first versus whatever's on the x-axis. Now, notice that distance is on the y, and so that's what comes first in the title, and then time is on the x-axis, and that's what comes second in the title. Now, let's say I have a graph, a distance versus time graph that looks something like this. Well, we know that slope is equal to rise over run. So the rise in this case is distance and the run is time. Okay, and we can calculate that by doing the difference between in the y-axis, the final point on the y-axis minus the initial point on the y-axis, and then that's over the final point on the x-axis minus the initial point. So saying if I took, this point and this point, right, the first point over here would be my initial point, and then this one over here would be my final point. So slope ends up becoming distance over time. Well, we know that distance over time is the equation for speed. So the slope of a distance versus time graph represents the speed of an object. So I can look at this graph and I can tell that the object is moving some distance over a period of time, and therefore it has to be moving, right? And it has some sort of speed. When we calculate the slope, it tells us the speed of the object. Now, I also want you to think of the units here. So the units for distance would be meters, and the units for time would be seconds. So again, if we're looking at units for slope, it would be meters over seconds, and meters per second are the units for speed. Okay, so it's very, very important that when you look at a graph, the first thing you look at is this y-axis, because as we're about to see, we're going to look at a graph now that's speed versus time. So it has the same thing on the x-axis, but it's the y-axis that tells you that it's different. So we'll go ahead and move on to this as soon as I can click here. And I'm going to get rid of all of this here. Okay, so now what we're looking at is a speed versus time graph. And on this one, again, we've got the time down here on the x-axis, but now the y-axis is different. It's speed. So we could have a graph that looks exactly the same as the last one, but it's showing us something different here. In the last graph, this line represented an object that was moving some distance over some period of time. And while it looked the same, it actually represented constant velocity because the movement was uniform. In this example, the speed is constantly changing. So it might be easier to visualize this if I draw some hash marks on here and we sort of label them as like 5, 10, 15, 20, 25, 30, right? So we can see here that the speed of this object is increasing over time. So we learned yesterday that increasing speed means that an object is accelerating. Now, once again, let's look at the slope here, and we look at rise over run, and on the rise, the y-axis, you see speed, right? And then on the x-axis, the run, you see time. Well, again, yesterday we learned that the definition of acceleration was a change in velocity over time. And here we're seeing a change in speed over time, which would be changing velocity. And so our slope represents acceleration. Remember the equation for acceleration. I'll write it up here. Acceleration is equal to, we write it out like this, the final velocity minus the initial velocity of the object over time. Well, another way to write that would just be the change in velocity. That's what that little triangle means, the change in over time. Well, that's what we've got right here. Change in speed over time. Remember that that if you're changing your speed, you're changing your velocity. And so our slope is acceleration. Now, again, I want to look at units here. Units for speed are meters over a second, and then units for time are seconds. So when you do meters over a second divided by seconds, you're going to end up with the units for acceleration, which is a meter over seconds squared. Okay, so meters per second squared are the units for acceleration. So please make sure that when you look at these graphs, the first thing you look at is that y-axis, because I just drew the exact same line on the graph. In the first graph, the distance versus time graph, it represented an object that was moving at a uniform rate, meaning a constant velocity. But this graph, since it says speed instead of distance, when I draw the same line on the graph, it actually shows us that the object is accelerating. So that is a very big distinction that we want to be able to make there. So now here's an example where the distance versus time graph is curved this time. The speed versus time graph is the same one that I just drew. So we talked about on the speed versus time graph how this one means that the object is accelerating. And specifically, this would be positive acceleration. The object is moving in the positive direction and speeding up. Now, coincidentally, the distance versus time graph shows us the exact same thing. Remember that the slope of a distance versus time graph represents the speed, right? So if the slope is changing, which it is here, right? The slope starts flat and then it gets larger and larger and larger. And when I say larger, I mean more positive. Since the slope is changing, that means the speed is also changing, since the slope represents the speed. And if the speed's changing, then that means the object is accelerating. So this graph also shows us positive acceleration. Okay? So these two graphs look very different, but they actually show us the same exact thing. So when you're looking at these graphs, you really want to pay attention to what's on the y-axis first, and then start thinking about the slope and what it's doing, what it means. And then you can kind of visualize what's going on with this object. Okay. Let's move on. So again, just to kind of reiterate a couple things here. The first thing you want to do when you look at a motion graph is identify the variable that's being measured on each axis, and specifically the y-axis when we're looking at these motion graphs, because in both of them you have time on the x-axis, but it's the y-axis that really tells you what's going on. Then you want to visualize the motion of the object by thinking about the slope. What does the slope mean? And then what is the slope doing? If the slope means speed and the slope doesn't change, then your speed is constant. If the slope means speed and the slope is changing, then it means your speed is changing and therefore the object is accelerating. And then on the flip side, when you're looking at a speed versus time graph, your slope means acceleration. So if the slope is constant, your acceleration is constant, meaning that the object is constantly speeding up or constantly slowing down. This should be a nice little intro to your motion graphs. You're going to do an assignment. There's another video that walks you through how to do your assignment.